Start. Welcome back to another Math Vibes video. In today's video, we'll be going over how to find the inverse of a function and how to graph that inverse of the function and then how to analyze that graph. So let's go ahead and get started. Let's start this video off with a simple example like a linear graph. Let's take y equals 4x plus 3 for example. How will we find the inverse of this function? So one thing you need to know for inverses is you need to swap x and y. That's just the number one rule when it comes to inverses. It's just the general thing you need to know. So what we're going to do in this example is we're going to swap x and y. So we're going to get x equals 4y plus 3. And then we're going to go ahead and subtract 3 from both sides. If you subtract 3 from both sides, we'll get x minus 3 equals 4y. And to isolate y, so we can get it back into the y equals mx plus b form, which is what you're always looking for, we're going to go ahead and divide by 4 on both. We're going to go ahead and divide by 4 on both sides. So we're going to get y equals x over 4 minus 3/4. X over 4 is the same as 1/4 x, so just keep that in mind. So this right here is our inverse from this function that we were given. So let's go ahead and graph our inverse. So I'm just going to write our inverse over here. Now let's graph both the function that we were given and the inverse of that function. So I'm going to graph both of them on the same graph so you can see how they contrast. So for the first one, I'm going to put in white. We're going to use the y equals mx plus b formula. This is our b, so that's our y-intercept. So we're just going to go to 3 here. And then we're going to go down 4 into the side 1. I'm going to do that one more time. And then I'm going to go ahead and draw a line through those points. So that's our line corresponding to the function that we were originally given. So let's go ahead and graph the inverse of the function that we were given. So our y-intercept is negative 3/4, which is 0.75, which is right here. And we want to go up 1 and to the left 4. So right here. Or right here, actually. And let's go ahead and do that over here. So let's go ahead and go down 1. 1, 2, 3, 4. So we're going to be right here. Let's go ahead and draw a line through all those points. So this is the graph of the function that we were given and the inverse. So that's how you find the inverse of a linear function and how to graph both of those functions. If you're finding this video helpful so far, feel free to drop a like and subscribe. And join a Discord server, which is linked first in the description down below if you have any similar questions to the ones in this video. And feel free to comment as well if you have anything to let us know about. So let's go ahead and try one more example with rational functions this time. And we're going to use fractions. So first off, how would we even graph this function and how we find the inverse of this function? So let's go ahead and find the inverse first. So we want to swap x and y here. I would say fractions are a little bit more difficult, but there's also a simple way to solve them, a simple way to solve for y in this equation. So first we're going to cross multiply. This is the same as x over 1, so we're going to cross multiply both sides. So we're going to get x times 3y minus 1 equals 5y plus 3. And then we're going to distribute the x. So we're going to get 3xy minus x equals 5y plus 3. We're going to go and move over here. Then we want to subtract the 5y from the right and move it to the left. So we're going to get 3xy minus 5y, and we're going to move the x to the right. So we're going to add it, equals x plus 3. Now we have a common factor here, which is a y. So we're going to go ahead and factor out that y. And then divide by this, so that we are left with y. So our final uh answer will be x plus 3 over 3x minus 5. So that is our inverse from this function right here. So I'm just going to go ahead and write this over here. I'm going to go ahead and make some space. So let's go ahead and graph both functions. This is going to be a little bit tricky because they are rational functions, so it might take up a lot of the graph, but we'll make it work. So the way to graph rational functions is asymptotes and then points. For the sake of this video, I'm not going to plot actual points. I'm just going to graph the general shape of the rational function. But let's go ahead and find our horizontal and vertical asymptotes. To find the vertical asymptote, you want to set the denominator equal to 0. So if you set that equal to 0, we get 3x equals 1, and we get x equals 1/3. So our vertical asymptote will be at 1/3. And vertical is up and down. So this will be 1/3 right here. And it'll go right through here. To find our horizontal asymptotes, you need to look at the exponent of the x's. Since both of these are raised to the first power, and on the numerator and the denominator, and they're the same power, our horizontal asymptote will be a over b. So our horizontal asymptote will be 5 over 3. If this doesn't make quite sense to you, you can check out my other video on graphing rational functions to fully understand this. But 5 over 3 is the same as 1 and 2/3. So it's about 1, maybe right here would be 5 over 3. Horizontal is left to right. So we're just going to go through here like that. And our shape should look something like this. So that is how you graph the given function, the given rational function. So let's go ahead and also graph the inverse as well. To find our vertical asymptote, we'll do the same thing and set the bottom equal to 0. If we solve for x, we get x equals 5/3. So our vertical asymptote for our inverse will be at 5/3. So 2/3, 3/3, 4, maybe over here somewhere, you could say. And to find a horizontal asymptote, it'll be the coefficients because, again, they are raised to the same power. So our coefficients is 1 and 3. So our will be y equals 1/3. That will be our horizontal asymptote. 1/3 is around right here, I would say. And then we're going to go ahead and graph the general shape as well. So it does look a little bit mumbo jumbo, but this is how you graph the inverse and the function, the original function that you were given. Now, if you notice one thing, our vertical asymptotes and horizontal asymptotes are flipped. So as you can see here, our horizontal asymptote, let me change my color. As you can see here, our horizontal asymptote was 5/3 and our vertical asymptote was 1/3. And if we look here, our horizontal asymptote was 1/3 and our vertical asymptote was 5/3. So as you can see, these are clearly flipped. And that's a great indicator that you did your mathematical computations right because they are switched. Our vertical asymptote now becomes our horizontal asymptote, and our horizontal asymptote now becomes our vertical asymptote. So that's how you find the inverses of linear functions and rational functions, how to graph your inverses, and how to check to make sure that you did everything correctly.